We talk a technical definition of a polygon. It is a closed figure with a finite number of sides, so it can't be an infinite. There's no such thing as an infinite-sided polygon. Okay, and the sides are line segments, not full lines. They connect together at the endpoints. So the sides that share an endpoint can't be collinear, which means that the sides of a polygon don't make straight lines. They have angle to them. And each side intersects exactly two other sides, but only at the endpoint. So you don't have, I'm just going to draw something weird like this, and then doing that, where this side intersects two sides, but not in it. This is not a polygon. It has to intersect only at the endpoints. Okay. Now that intersection is a vertex. And that's the intersection of the sides. And is the end point of the segments. And it's like the same thing as a vertex of an angle, because each time a polygon's sides intersect, they form an angle. Okay, so when you have like the sides of, say, a square or a rectangle, we have an angle. So okay. So examples of polygons, actual polygons. Okay. We can have triangles. That's not a polygon. Let me make it pretty. And dotted. I don't want it dotted. Hold on. Okay, triangle is a polygon. Trapezoid, you can have things that do things like that. Oops, that's not what I meant. Okay, you'll notice these are all closed, and every side intersects another side at a vertex, and no lines, segments continue past the sides.
So we cross like the beginning point of the vertex? Or like
It's each vertex is here. These are the endpoints of the line segments, and that the lines only intersect at the segments. And so you don't have, okay, for example, something that would not be a polygon would be a shape like that, because this line and this line intersect not at an endpoint. They're intersecting in the middle. If it's not closed, it's not a polygon. If it has curves, it is not a polygon. Any kind of a curve, not a polygon. Circles and ovals are not polygons. Polygons are made up of line segments, and so circle, has line segments. It's one big curve, so not a polygon. And then anything that has, like some little piece that's from a side hanging out, also not a polygon. So, oops, push one button. There are two formal definitions for concave and convex. Okay, the first deals with the diagonals. Now, if you are talking about a shape, okay, the diagonals are the lines that go from one vertex to another. These red lines here would be the diagonals of this rhombus. If you're concave, all of your diagonals are on the inside. If you're convex, that's a bad drawing. Oh, never mind, that turned out good. If you're convex, your diagonals can extend outside. So diagonals connect vertices. So this one has 1, 2 diagonals. But see how this diagonal is outside. Or we can look at the lines extending outside of the figure. And if you're concave and you extend your lines out like this, all of your intersections are happening outside of the shape. Right? Here's an intersection, here's an intersection. So it's happening at the vertices, but they're staying outside of the shape. Whereas if I'm convex and I were to extend lines out, hold on, let me draw another convex. Okay. So all my lines, see how all my lines are outside? Here, my lines are crossing inside the shape. So inside, these two are staying outside, these two are staying outside, but these two have gone inside the shape. So lines intersect or cross into the polygon. So you can look at two things. You can look at either your diagonals or you can look at your outside lines, whatever one is easier for you to visualize. I personally think the outside lines are easier to visualize, but it's up to you. We're going to determine if these are concave or convex. And like I said, I think the lines to the outside are easier than trying to do all the diagonals. So I'm just going to use those. If I do this, I'm just crossing, like I'm extending my lines. Do you see how none of them go inside the polygon? So this is convex. Because if I extend the lines, none of them cross into the inside of the polygon. Here, look, if I extend this line, see how it goes into the inside of the polygon? Like if I were to extend the line. No, I'm saying if I extend it, if I continue it. Like if I continue this line, it'll just keep going on and on forever and ever and ever, but it never goes inside.
So convex doesn't go inside.
Yes. And concave, here if I extend this line, if I extend it, it crosses into the interior of the polygon. Do you see that? So then that's concave.
So how is a square concave?
A square is not concave.
But you drew lines inside.
No, I'm not perfectly, I can't draw that perfect. Oh, up here, these diagonals. There's a difference between diagonals and extending the sides. Here I'm extending the sides. If I draw the diagonals, the diagonals connect the vertices. If the diagonals are all inside and the lines of the sides are all outside, you're convex. If your diagonals go outside and your lines come inside, you're concave. So you need to pick, you need to pick one or the other. Do you like diagonals or do you like the sides to extend? Because you want to remember one way to make it less confusing. I personally like the sides to extend because I think it's easier to catch all of them because I know how many sides there are, but I might miss a diagonal. Like, what if I'm doing all my diagonals and I forget that I need to connect this vertex to that vertex? Do you see what I'm saying? Yeah, you would have to if you're doing diagonals. So I say extend the lines. If I extend all the lines and none of them go inside, I'm convex.
So the star is concave?
Yes.
Okay.
Yes.
And with the concave, the diagonals extend
Past the sides, yeah. So here, when I extend this line, I don't have to do all the lines. Once I extend this line, it's gone into the star. So concave. Whoops, concave is with a C, not a B.
How come you don't, for the first one, run stretch the line across to do?
Here?
No,
Here.
Yes.
I did all of,
Like diagonal, like.
I'm not doing the diagonals, I'm doing the outside sides.
Just doing the inside, and we count if.
The reason I suggest not doing my diagonals is because it's easy to miss diagonals. It's easy to miss, like you have to try every diagonal to make sure, and it's easy to miss a diagonal, but it's not easy to miss drawing a line along the sides because you can easily see how many sides there are. Does that make sense? So I recommend doing the sides, and if you draw a side and it comes inside the polygon, it's concave. If you draw sides and they don't go inside, they're convex. So this would be, if I draw these lines, are they going to go inside? No. Yeah. And this? And this?
Yes.
Okay, shape.
Kind of looks like a dragon.
Well, let's see. Technically, this is a 1, 2, 3, 4, 5, 6, 7, 8, 9. That's a nonagon because it has 9 sides. It is just not a regular nonagon.
If you look from the side, it kind of looks like Gryffindor from like the early Spider-Man.
Cool.
When it was still.
Polygons. Polygons are named based on the number of sides because the prefixes mean the number. Tri means 3, quad means 4, pent means 5, hex means 6. It's from the Latin roots. So we have up to 10 on this chart, which is a decagon. But I wanted to. You guys heard of like equilateral triangles? Well, we have equilateral polygons, and that's just any polygon where all the sides are the same length. And those can be your odd shaped polygons. When, like, I could have drawn something like this if I had made all the sides the same length. It would be equilateral. Equiangular just means that every angle is the same. The sides don't have to be the same length, but the angles are. So if you look at your basic standard 5-pointed star drawn correctly, all of the vertex angles are the points of the star, and all of those angles would be the same. So we could call this like a equilateral. Okay, square. Right? Because squares have the same size. Same length of sides. Right? All 4 sides of a square are the same length. Equiangular would be like a perfect 5-pointed star. All the vertex angles would be the same length. And then regular polygons. Regular polygons are polygons that have the sides are the same length and the angles are the same measure. So stop sign is a regular octagon. All the sides of a stop sign are the same length and all the angles are the same. Okay. You can't have a concave regular polygon because as soon as you become concave, it's impossible to have equal angle measures. If we look at some of our concave examples, there's no way that all of these angles could be the same because we have some going in. Does that make sense? Like bending?
No, I get it.
Okay.
Challenge.
There's not any. Okay, I have to put some marks on this really quickly. Okay, so we're going to look at these. We're going to name each polygon. We're going to say whether it's convex or concave and if it's regular or irregular. Okay. So when I look at this, I have 1, 2, 3, 4, 5, 6 sides. Concave or convex? Right, because all of the sides would be outside. And regular or irregular?
Regular.
Regular.
Why, how's that regular?
Because all of the angles are the same and all of the sides are the same. Okay. Now, how many sides? So it's a quadrilateral. Concave or convex? Regular or irregular? Irregular. You think of rectangles as very regular, but they're actually irregular because all 4 sides have to be the same length for it to be regular.
A square is regular.
A square is regular, yes.
Okay.
But because these 2 sides are longer than these 2 sides, we're irregular. We are, however, equiangular, even though we're not equilateral. Okay, here we have 5 sides, so we're a pentagon. Concave, convex, regular or irregular?
Regular.
Do you know that for sure?
You have the little lines on there, so it's saying.
But I haven't told you anything about the angles. You have to have both the lines and the angles to know for sure.
So if you don't know for sure, it's automatically irregular?
Yeah, if you have to know for sure, like 100% that the lines and the angles are the same. Now, if you wanted to get out a protractor and measure all of these angles, you could do that. And then you could say for sure, but with just the markings I've given you, you have to say this is irregular because you don't know for sure the angles are all the same. Does that make sense?
Mm-hmm.
Okay. Concave or convex? And it has 1, 2, 3, 4, 5, 6 sides, so it's a regular or irregular?
Irregular.
Yeah, some of those are really easy. Like as far as regular, irregular. Okay, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 sides. Regular, irregular?
Regular.
Your sides. Oh wait, sorry. Your sides and your angles are have to be the same length, but even more so, you have to be convex. Because it's not okay. These 5 angles are the same, but these 5 angles are not, are they?
Why not?
They have to, all of the angles have to be the same. This star has 10 angles. These 5 angles out here are the same as each other. These 5 angles in here are probably the same as each other, but all 10 angles are not the same as each other, right? This angle and this angle are not equal. You see that?
Is it because like it's not the same on top side?
This is okay. If I were to measure this angle here in between the 2 legs of the star. Oops, hold on. Oh yes, I can't with this protractor because it's more than 180 degrees. Right? See that? It's going to come around and over. I can't measure it with a regular protractor. I have to get like a polar, like a circular thing, and it's going to be more than 180 degrees. This angle in the leg of the star is 35 degrees. So this angle is 35 degrees, and this is over 180.
Well, couldn't you measure the outside part and then just subtract that from 360?
Yeah, I can do that.
How much is it?
It is 85, so 360 minus 80 is 280, right?
Yeah, 280.
And then so 675. 35. So they don't match. So it's not regular. But more so, no concave polygon is ever going to be regular. So if it's concave, it's automatically irregular. Okay? Okay, perimeter is just the length around the outside of a figure, so you can add up all the sides. Circumference is the length around the outside of a circle.
And the radius is half of that, right?
No. Circumference is the outside, the round, like this length right here, around the outside of the circle. The diameter is the center crossing the circle. Hold on, I'll write that down. So you're going to use the formula to find this. If I have a circle, okay, the length going completely across the circle is the diameter. The length from the center of the circle to the side is the radius. So diameter, it cuts in half. And radius is 1/2 of the diameter. So from center to side. Area is the amount of space a shape takes up. And that is in square units. So square feet, square inches, square centimeters, square millimeters, square miles. And it's literally, it is the number of squares. So if you say square inches, you're talking about little 1-inch squares, and how many of these little 1-inch squares are going to fit inside that shape. Okay, perimeter and or circumference of each. If this is 3.2, that makes this also 3.2, and if this is 2.1, this is also 2.1. And I can add up all the sides. Or I can do 2 times the 2.1s because there's 2 of them, plus 2 times the 3.2 because there's 2 of those. Okay. Now perimeter is just length, so it's just units, no squares. Okay, circumference of a circle is 2 pi r. What am I doing?
Oh, that is radius squared.
That's area. Now, circumference and area can be confusing because they both have a pi, they both have an r, and they both have a 2.
Okay.
But area is squared. And so that'll help you to remember that with the area, it's the radius that's squared. And then circumference is just length, so you're not squaring anything. Hopefully that'll help. So I'm going to put in the 2. We're going to use 3.14 for pi times 3. So I get 18.84 inches.
So we can't just write 6 pi.
You could. Perimeter of a trapezoid? Yes.
So it's 2 times 3.14, and then whatever that comes to times 3?
Yes.
And you could do...
Or you could do 6 times 3.14.
So
or
you could do it in any order.
Yeah, because it's multiplication, so it doesn't matter what order you do it in. Now, perimeter is area all around the outside, so don't let this confuse you. We don't need this. We're talking about just the outside.
For example, if it says find the area of just that.
The area of this?
Yeah.
There's a
right.
formula for that, which we need the height for.
And then you just do first the height and the base.
We're not there. We're just doing perimeter right now. So
33.5 millimeters.
thank you. We're going to add all those up and we're going to get 33.5 millimeters. Okay. Perimeter of a triangle, same. We're just going to add up the sides.
I'm gonna get 29.5.
29.2 inches. Now, circumference of a circle, we can use 2 pi r, or you can use pi times the diameter, because 2 times the radius is the diameter. So circumference is either 2 pi r, or you can use pi d. So that's going to be 6.2 times 3.14. Oops. What was it?
19.468.
I'm just going to say 19.47 centimeters. And finally, when we have a parallelogram, opposite sides are the same length. So I have 2 times 18 plus 2 times 9.3, so that's 36 plus 18.6. Oops, 6, not 4. So 54.6. Area of rectangle is, so I can do 3.2 times 2.1.
6.72.
And those are square centimeters. Okay, circumference, or sorry, not circumference, area of a circle is pi r squared. So 3.14 times 3 squared, which is 3.14 times 9. So it's 28.26 square inches. Okay, area of a trapezoid is 1/2 the base plus the base times the height, or you can do base 1 plus base 2 times the height divided by 2. So base 1 is 6.5, base 2 is 13.5, my height is 5.5. I'm going to divide all of that by 2.
55 millimeters.
Okay, that's 20 times 5.5. Okay, I can't type. So that's 110 divided by 2. That's 55. Okay. Area of a triangle is 1/2 base times height, or you can do base times height divided by 2. So I've got 10.2 times 8 divided by 2. And that's square inches. Okay, now on this one, I have to find the radius, which is the diameter divided by 2. So that's 3.1. Okay, 3.1 squared is 9.61. And that times 3.14 is 30.18. That's centimeters squared. Sorry, that's so squishy. And then finally, the area of a parallelogram is base times height. So that's 18 times 12. So 216. So we're going to find the perimeter and area of a triangle with these vertices. So first I'm going to draw the triangle. -3, -1, and 4, -1. Okay, so here's my triangle. Okay. The length of this flat line is fairly simple to calculate. I can count, right? I have 1, 2, 3, 4, 5, 6, 7. So that length is 7. The length of this line and the length of this line I'm going to have to calculate. So you guys remember our distance formula? Okay, so this was -3, -1. This is -1, 3, and this is 4, -1. So I'm going to find the distance between these 2 points and those 2 points.
So on a graph, that's always gonna, we can always just count.
If it's a completely horizontal line or a completely vertical line, you can count. If it's a diagonal of any kind, you have to calculate. Because I can't count the number of squares here because I'm not getting even squares. Okay, so I'm plugging in x and y. So I've got -3 minus -1, which makes +1 squared, plus -1 minus 3 squared, which gives me -2 squared plus -4 squared. So that's 4 plus 16. So that is the square root of 20. And because I'm going to need to find the perimeter and area, I'm actually going to go ahead and figure that out. And I'm going to say it's 4.5. Then I'll find the distance of the next side. So this side is 4.5. Using these 2 points. So I have -1 minus 4 plus 3 minus -1, so 3 plus 1. So -5 squared plus 4 squared. 25 plus 16. 41. So 6.4. Okay, so now I can find my perimeter. And I have no idea if these are inches or anything, so I'm just going to say units because I don't know what they are. I have my base. My base is 7. What am I missing? Oh, shoot, that was way too big, sorry. Yes, I'm missing the height. Now the height is going to be from the vertex straight to the base, right? That makes a straight line, so I can count the spaces. 1, 2, 3, 4. So my height is going to be 4. So this is going to be 1/2 of 28, which is going to be 14 square units of some sort. Now in this example, it's really nice because it gave us a right triangle. So I can count this length and I can count this length because they're both horizontal and vertical. So I have 1, 2, 3, 4, 5. And then I have 1, 2, 3, 4, 5, 6, 7. Okay, 2 ways we can find this length here. I can either use the distance formula or I can use the Pythagorean theorem. Want to use the Pythagorean theorem? Okay. So the Pythagorean theorem is a squared plus b squared is equal to c squared. This is a, this is b, here's c. So I'm going to take 5 squared plus 7 squared to equal c squared. 25 plus 49 equals c squared. See, that's 69 plus 5, so 74 is equal to c squared. And then to find the answer, I take the square root of 74.
Oh, you don't plug it in. Okay.
And I get 8.6.
Wait, when do you square it?
Oops. No, when do I square it or square root it?
Square root it.
Once I have the 74. Once it's added together, then I square root it.
So you don't try to square the 74?
No, because I squared the 5 and I squared the 7. Then I add those together. That 74 is equal to c squared. So to find out what c is, I take the square root of both sides.
Just to find the square root.
Mm-hmm.
What do we find the area?
Well, that's to find the sides lengths. I'll need to do the same thing if I'm finding the area also. So now the perimeter is 5 plus 7 plus 8.6. So that's 20.6. And the area is 1/2 of the base times the height. And because I have a right triangle, this is the base, here's the height. In a right triangle, your base and your height are your legs. So I have 1/2 of 5 times 7, so that's 1/2 of 35. Well, 1/2 of 36 would be 18, so that is 17.5. And we have square units because it's area. Yeah. Yes. Okay, so when we look at a practical problem, if you have 32 feet of fencing, you can figure out what dimensions will give you the largest area by looking at shapes with different lengths. So if I do a circle with radius of 5 feet, I could do 5, well, it's pi r squared, right? So pi r squared, so 3.14 times 5 squared, so 3.14 times 25.
The circle with a radius of 5, how would you know that's finding the area?
It's because it says what shape play area uses the most or all of the fencing and encloses the largest area. So I found this area, now I need to find the circumference. So that's 20 times pi. So we have 62.8. Okay, 62.8 feet is way too big. We can't use that one. We only have 32 feet of fencing. A rectangle with a length of 5 and a width of 10, well, that perimeter would be 30. So we'd use most of the fencing, and our area would be 50. So that's practical. If I do a right triangle with legs of length 10, that's 10 and 10. So I can find the area easily enough.
Miss, how do you find 20? Where'd you get 20 from?
2 times 5, 2 times 10.
You're doing B right now, right?
Yeah.
I think you'd still do it.
Oh, no, sorry. Okay. I'm finding the area of this triangle is 50 feet. Same as the area of the rectangle. And I need to find the length of this other side, so I can use Pythagorean theorem. So 200 is equal to c squared, so I need to find the square root of 200, which is 14.14. So that would be 10 plus 10 plus 14.14, which would be 34, which is bigger than the fence we have, so we can't use that one. And if I did a square with sides of 8 feet, the perimeter is going to be 4 times 8, which is exactly 32. Yeah.
For the first one, circle of radius of 5.
Mm-hmm.
The circumference.
Oh, I did 20 instead of 10, huh? Sorry, yeah. Oh, so we could use that one. Sorry. We can still use that one. Thank you for catching that. Yeah, it should have been, I don't know why I did 20. 2 times r is 10, not 20. Okay, in the area of a square with okay. Here we use exactly all of the fencing, but we get 64 square feet of area. Here we use not quite all of the fencing and get 50 square feet of area. Here we use not quite all of the fencing and we get 78 square feet of area. And then here we don't have enough fence. Yeah.
So when it says like right triangle with legs of left 10 feet, so it's talking about 2 legs, right?
We've got 2 legs, but we have to find the other leg, which was 14.4.
How do we go with the circle?
This circle is the best option for the dog. It gives you the most area with the least amount of fencing.
So you use that for
Yeah, we're looking at area and perimeter because we need to know we have only so much fence and we want to make the biggest area for our dog.
So you also found the other side for the triangle?
Yeah, that's what this was right here, the Pythagorean theorem. That told me this length.
Okay.
And then this was the perimeter.